Hello everyone, welcome back to the channel. I hope you guys are doing well. So we will see today's daily challenge on Leetcode and we will solve it together. So I guess today's challenge is quite a simple one. You should definitely try this on your own before watching the solution. So minimum number of operations to make all the array elements equals to 1. So you are given a vector of numbers which is 0 index and consists only of positive integers. There is no zeros also in it. Okay, it is greater than 0. Each and element is greater than 0, each and every element. Okay, and you want to convert all of the elements to 1, and you can perform this operation any number of times. You can select an index I and replace either that index number or the next index number with their GCD value. Okay, so let's say GCD of nums of I comma nums of I plus 1, whatever will be that GCD value, you can replace that value to any of the ith element or the I plus 1th element. Okay, so adjacent elements to anyone you can replace by their GCD value, and you need to return the minimum number of operations to make all the array elements of nums equal to 1. If it is impossible to do so, you need to return -1. The GCD of two integers is the greatest common divisor of two integers. I hope you know this already. And let's try to run this example and try to understand how exactly we can make all the array elements to be equal to 1. 2, 6, 3, 4 is the thing. So 2, 6, 3, 4, and what you can do is that, let's say if you pick these two elements, okay, if this is the I and this is the I plus 1, uh, what is the value of GCD of 2 comma 6? It is 2. So you can replace either 2 by 2 or 6 by 2. Now if you choose to replace this 6 by 2, you get 2, 2, 3, 4, and the number of operations which you used just now is 1. Okay, and you see, if you now choose to select the GCD of 2 and 3, now you know that GCD of 2 and 3 is 1. So let's say you try to replace this 2 with 1, 2, 1, 3, 4. Now you used another operation, so in total you use two operations. This is your second operation. Now you know that GCD of 1 with anything, any other number, okay, is 1. So you can choose these two numbers and replace this 3 by 1. You can also choose these two numbers and replace the 2 by 1. You can again choose these two numbers 1 and 4, right? After doing that you will get something like this after doing these two. So after 4 operations you get something like this. Now you can choose these two to have all the array elements equals to 1. But if you see, you used 5 operations. Can you do in something lower than that? So what could you have also done is that, instead of selecting 2 and 6 in my first step, what I could have done is that I could have selected these two numbers. You see, I could have selected these 3 and 4 numbers, this to be I and this to be I plus 1. Now you know that GCD of 3 and 4 is 1. Okay, so you can replace 2, 6, 1, 4 in one operation. You did that. Okay, now in the second operation 1 and 4 you can turn it to 1. In the third operation 1 and 6 you can turn 6 to 1, and you can also turn this 1 and 2 with 1 with another operation. So total of 4 operations you used. Okay, so total of 4 operations you used to make the array 1. So what was the difference with the previous approach? The previous approach you used 5 operations, right? And here you are using 4, so this is the minimum one. So you see, basically you found a 1. So as you know that GCD of 1 with anything is 1, so you need to find a 1. So basically your goal should be to find a 1 as quickly as possible. Okay, because once you find a 1, see, your ultimate goal is to make everything 1, right? So once you find a 1 in minimum number of operations, that is in one operation with every other element, you can turn all of them to 1. Okay, so find a 1 as quickly as possible. It is the same as saying that uh, out of all sub arrays, out of all sub arrays, okay, uh, find the sub array with minimum length. Find the sub array with minimum length and GCD of all elements in that subarray equal to 1. I hope you do get it right. See, because at once in one shot you get a GCD equal to 1 here, but every time you may not get that, right? Every time in one shot you may not get your GCD to be 1. So what you need to do that in your whole array you want a subarray of minimum length. See, you want to find a 1 as quickly as possible, right? So you want to find a subarray of minimum length. So if you try to do GCD of this and then again GCD of the next with this and again the GCD of the next with this, you should immediately get a 1. Once you get a 1, let's say with k number of operations you get 1. Once you get 1, remaining, see, n elements are there, remaining there are n minus 1 elements which are not 1. So with this k operations, k plus n minus 1 will be your answer. K operations you use to get a single one, and with this single one you can make every elements to be 1 with 1 1 operations each. I hope you do get what I am trying to say. So yeah, here the subarray was only of 2 length, okay, but always you may not get the subarray of 2 length, so you might get something greater than that. So in order to find one as quickly as possible, what you need to do is simply to, out of all subarrays, find the subarrays with minimum length and GCD of all element equal to 1. Now can you iterate through all subarrays? Can you do a brute force? Is a brute force possible? So if you see, yes, it is possible, because you see what is the constraint, it is 50 just, right? And in, you can see, I can find all subarrays and also find the GCD of them in O of n square time complexity, you know it, I guess. Okay, so you can do that easily. You can go through all the subarrays. So go through all the subarrays, find the GCD of that, okay, of all the elements, and you also need to find like, if the GCD is 1, what is the minimum length of the all the subarrays, okay. So whenever you get that minimum length mn, all you need to do is mn plus n minus 1. So mn, so basically not, if the length of the subarray is, let's say, 2, okay, one operations, in one operations you can get uh, a single one. So if the length of the subarray is mn, in mn minus 1 operation you can get a single one. So mn minus 1 plus n minus 1, so mn plus n minus 2. So in whatever however way we calculate that, that will be true. So let's see what can we do. So I will do a simple thing, that is, I will do brute force. I will go through all the array elements, okay. So let's see, I want a minimum value, right, which is initially, let's say, n plus 1. So if I go through n starting from this, and let's say I am also having a j which is equal to I starting from, okay, and j is less than n j plus plus, okay, and you see you have a GCD, okay, GCD 0. So if you do not know, GCD of 0 with x, and x is any positive number, is always x, okay. So you can, it is safe to initialize GCD with 0 in case you are converting every element, I mean you are calculating the GCD of every element, okay. So so at the ending ending j point, okay, so j ends, so you see I tells you the starting point, right? So basically I tells you the starting point of the subarray. I hope you know how to find all subarrays and calculate an operation within them in O of n squared time, and this is the ending point of the subarray which you are considering, okay. So at every ending point you are just going and calculating the GCD g equal to GCD of g comma this nums of j, okay. So now you can simply check that if my current GCD is equals to 1, what I could have done, I could have calculated the minimum value, which is nothing but minimum of mn comma j minus I plus 1, okay, j minus I plus 1, okay. So this is the minimum length of the subarray, which is having a GCD of 1, and you can just tell that if mn is still equal to n plus 1, that is, it has not changed from the beginning. Okay, so see, through all these operations, the maximum value of mn you can get is n. Okay, if it is still n plus 1, it means that it cannot be possible to turn all the elements to 1. So you are not getting a single one at all. You are not getting a single one at all out of all the sub arrays also. So what you can do is simply return -1. Else you can choose to return mn minus n plus 2. Okay, so sorry, it's not. See, what was the formula which we derived? Mn plus n minus 2. So because mn minus 1 number of operations you require to make a single one, and you need to make still n minus 1 number of operations. So you need mn plus n minus 2 number of operations. Okay, this is what you need, and if you try to submit this, I hope this should work. You see, we get an accepted if you try to submit for all test cases. Let's see what happens. So you see, you get a wrong answer, and here we are output is 1 and expected is 0. Why expected is 0? Because all elements are already 1 and you need no operations. Okay. So if you notice properly, what we are doing, we are assuming. So in our approach, what was wrong in our approach? Okay, in our approach we were assuming something, right? What we were assuming, there are no ones and we make a 1. Okay, so we were assuming that we make a 1 and then use that one to convert all 0. So what if there are already multiple ones present? So let's say an array consists of 3 ones right now. Okay, and 5 and 6, let's say it's there. So how many operations do you need? So you need just one operation and again with 2 operations. So basically with one operation you will get 1 1 1 1 6, and with the second operation you can convert everything to 1. Okay, so you just need to see that what will be returning in this case is 2 operations. So how we will come to? So you count the number of ones, it is 3, and what is the total length of the array? It's 5. So 5 minus 3. Okay, so you can just choose to count the number of ones if it is greater than 0. So let's say I will do something else like this. Okay, and for int x nums, I will go through all the values of x, and I will tell that if x is equal to 1 once plus plus. Okay, I hope you can do this easily. There should be no difficulty in this, and if you can check that if once is greater than 0, then you can simply return something, right? You can return n minus 1s. Okay, so that's what we saw, that those many number of numbers which are not ones, we need to convert that to 1. Using one operation we will be able to do that, so that is n minus 1s. Now try to submit it. I hope this will just work fine. Yeah, this should work fine. Let's see. You see, we got an accepted with a 100% runtime complexity. Yeah, because n was just 50 and we have n square log m, probably because of this GCD calculation every time. So yeah, whatever be the case, you can also call it a simple n square, O of n square complexity. So I hope that is very clear, the approach is very clear to you. There should be no difficulty in this, and yeah, I hope you were able to get some idea on your own also for this problem, because it is not at all difficult. Yeah, even if you are struggling with such problems, do not worry, just keep practicing and you will definitely improve. So that's all for this video. I will meet you in the next video. Till then, thanks a lot.